In this video, we are going to try to learn linear equation in one variable, and specifically we'll try to learn finding domain of the variable. Okay, so let us see some example of linear equation in one variable. Okay, so let's see. Number one, we have 2 equals 5 over x minus 1. So this is one of my linear equation. Let us see my number 2 example. I have x minus 2 equals square root of x. And then let us see the number 3. I have 2x minus 3 equals 7. So these are my 3 linear equation. Okay, now if you notice, all the equation actually have only one variable. Okay, so if I wanted to show you, so you see for this equation I have only one variable x, and in this equation also, the second equation, I have only one variable x, and also in the third equation I also have only one variable x. So all the 3 example I have only one variable. Okay, and those are all linear equation. Now so first of all, now see, we want to try to find domain. So before we try to find domain, let us first see the definition of domain. So let us see a plain definition. So plain definition of a domain is what the domain of a variable in an equation is the set of all real number for which both sides of the equation are defined. So let me try to explain. Okay, so what did it say? It says that domain of the variable is the set of all real number for which both sides of the equation are defined. Okay, so let us first try to find the first one. Okay, so for the number 1 equation, let us see the left hand side. Now the left hand side I have only a number 2. Now number 2 is always defined no matter whatever the x value is, so we are fine in left hand side. Now let's look at the right hand side. Now in the right hand side, what I have? 5 over x minus 2. Now if let's say x equal to 0, what happens? So let us see what happen if x equal to 0 in my right hand side. So what I have? I have 5 over 0 minus 1, so which is what? 5 over negative 1. So this is still defined, so we can still calculate it. Okay, now what if x equal to 1? So what is going to happen if x equal to 1? It is going to be 5 over 1 minus 1, which is going to be equal to 5 over 0. Now 5 over 0 we are never going to be able to calculate. If you punch your calculator, it is going to give you error. Because why? If my denominator is 0, then you cannot compute. So that means what? That means 5 over 0 is not defined. That means we cannot calculate it. So that means x cannot be equal to 1, because if x equal to 1, then my right hand side of the equation is undefined. So x equal to 1 is not a domain. Now let us see. So this is one example, and then we can continue what is going to happen if x equal to 2, and what is going to happen x equal to 3, on and on and on. Okay, so these are the OA. So now let's see a classical definition. So first of all, we know that whenever I have this type of numerator and denominator, so I know that my denominator cannot be equal to 0, because if my denominator is 0, then my right hand side is going to be not defined. So I can write actually, so let me erase some of this portion. So let us say, so I know that the denominator, that means whatever is inside this yellow circle cannot be equal to 0, because if it is 0, then my denominator is going to be 0, and I cannot define the right hand side. So what is inside my this yellow box? It is going to be x minus 1. So x minus 1 cannot be equal to 0. So I can write what? So x minus 1 cannot be equal to 0. If I bring that 1 into this side, what I get? I get x cannot be equal to 1. So this is so except x equal to 1, all the number, all the real numbers are fine. So that means except for x equal to 1, all the numbers satisfy both left hand side and right hand side. That means the equation is defined. So this is one way of representing the domain. So this is called domain. So the domain of this particular equation 1 is what? X not equal to 1. That means except x equal to 1, all the other number make that equation defined. Now I am going to show you how to express this domain in interval notation. Okay, so for that I am going to take advantage of number line. So let me try to draw a number line. So let's say, so this is my number line. Okay, so that number line represent x. Now let's say this is my 0 point, this is my 1 point, this is 2, this is 3, this is 4, this is -1, this is -2, this is -3, on and on. Okay, now let's see what is my domain. Says that x cannot be equal to 1. So that means that x cannot be 1. So that's why I put a hollow circle, and except x equal to 1, my all other numbers are fine. So if I put a black color, so that means all these numbers satisfy my domain. Okay, so which are these white number? So if I try to find this portion of the white number, so it is starting from where? Starting from negative infinite until what? Until 1. Remember, 1 is not included. That is the reason I am putting a parenthesis. Okay, now for this portion is what? From 1 until positive infinite. So it is 1 until positive infinite. So these are the two separate portion, and I am going to add them by a union sign. So this is actually the interval notation of my the same domain x not equal to 1. Okay, so this is in what notation? Interval notation. So this is domain for my first problem. So let us now see how we can find the domain for the second problem. Now for the second problem, let us see first, look at the left hand side. Now left hand side is what? X minus 2. Now if I put x equal to 1 minus 2, I can still calculate. If I say x equal to 2, I still can calculate 2 minus 2, which is 0. That's still fine, calculable. And if I put x equal to 1000, still 1000 minus 2, it is calculable. So that means for left hand side, any real number of x is going to work out for the left hand side. Now let's look at the right hand side. Now in the right hand side, you see I have what? Square root of x. Now if I say x equal to 2, so if I say x equal to, let's say 4, so it makes our life easy. So what is going to be my right hand side? It is going to be square root of 4, so it will be 2. So I can calculate it, no problem. If x equal to 0, square root of 0 is going to be still 0. So that means still I can calculate. Hey, what about if I say x equal to negative 4, just putting a number. So what is square root of negative 4? Now square root of negative 4 we cannot calculate. So this is not in a so this is not going to be a real number. So that means what? X and that's true for any negative number. If I say x equal to negative 1, that means what? Square root of negative 1, still it is what? It is going to be a non-real number. So x cannot be negative. So what is the bottom line? Bottom line is, whenever I have a square root, that means whatever is inside, underneath the square root, that means inside the yellow circle, so inside the yellow circle must need to be what? Greater than or equal to 0. It cannot be less than 0. Less than 0 means any negative number is not going to work. So whatever is inside this yellow, that means underneath the square root sign, must need to be greater than or equal to 0. Now what is now inside my yellow circle? It is x. So x need to be greater than or equal to 0. So this is the domain for this particular problem. Now let us again try to represent the domain using interval notation. So let me first draw an number line. So this is my number line, and again I have what? X equal to 0, 1, 2, 3, negative 1, negative 2, so on and so forth. So this is the number line representing the value of x. Now we know that x need to be greater than or equal to 0. So greater than or equal to 0 means what? So that means the x can take a value of 0, and then it can take all the value in the positive zone. Okay, so what are the value it can take? This line, so it is going to be starting from 0 to positive infinite. Now if you notice one thing, 0 is included in the domain. That means what? X can take 0. So that is the reason I put a what type of sign? I put a bracket. So that means I am going to put a bracket. So this bracket denotes that the 0 is included in the solution. Like unlike the previous one, here I put what? A parenthesis. A parenthesis mean this number 1 is not included in the solution. So this is my domain, the same domain expressed in that manner. So personally we prefer the interval notation. So this is the interval notation. So this is the domain for the problem number 2. Now let us see the problem number 3. So first of all, let's look at right hand side. So right hand side is a simple number, so for any value of x, right hand side is defined, no problem. Now let's look at the left hand side. So left hand side is 2x minus 3. So even if I put x equal to 0, 1, 2, 3, or x equal to -1, -2, -3, no matter what number I put, I still can compute the left hand side. So for the problem, this problem, x can take what? Any real number. So for any real number, this equation is defined. So if I draw a number line, you know, 0, 1, 2, -1, -2, so that means what? That means my you know, it is the solution of what? The whole number line. And as you can understand, the whole number line is what? Starting from -infinite to +infinite. So this is the domain for my third problem. Okay, so this is the domain, all real number. So these are 3 examples. So now I still want to do another example so that it is clear to all of you. So let us see, let's do another example, finding domain of a variable in a you know. So let's see. So number 4. So the problem is, the equation is 3x over x minus 3 x minus 4 equals 2x plus 9. So this is my you know, equation. Okay, so this equation, I have only one variable, as you can see, only x. So our objective what is to find the domain of this equation. So first of all, let us look at the right hand side. So as you can see, right hand side, what I have? 2x plus 9. So for any value of x, 2x plus 9 I can compute. So that means 2x plus 9 is defined for any value of x. So right hand side is fine for everything. Now let's look at left hand side. Now in the left hand side, as you can see, I have denominator. Now as you can see from you know, our previous example 1, as you can see here, the denominator cannot be 0, because if denominator is 0, then the equation is not defined. So let us see now for this particular example. So I know that the whole denominator cannot be 0. Okay, so this denominator cannot be 0, that is the condition. So I know that what? I know that this box cannot be equal to 0, and we know what is inside. It is x minus 3 and x minus 4. Now let's look at in another angle. So now let's look at separately. If what is going to happen, if x equal to 3, look at here, what is going to happen? If x equal to 3, what happened? X equal to 3, so 3 minus 3 is 0. So 0 multiplied by x minus 4 is 0. So that means what? If x equal to 3, the whole thing become 0. So x cannot be equal to 3. Okay, so now how do I find x equal to 3? So what I am going to do is, I am going to take only one portion. So this portion cannot be equal to 0, as we can understand. So this portion also cannot be equal to 0. So what is inside this portion? Inside this portion is x minus 3. So x cannot be equal to 3. So this is at least one answer, so that means that is also one domain. So now let us look at the other portion. As you can see, we know that x minus 4 also cannot be equal to 0. So what is happening here? It is that this portion also cannot be equal to 0. So what is inside it? It is x minus 4. So that means x cannot be equal to it should be 4. So x cannot be equal to 4. So now what is my domain? My domain is x cannot be equal to 3 and x cannot be equal to 4. So these are my domain. Now of course I express this domain in that fashion. Now again let's try to express the domain using a number line, because using a number line, that is actually better. So let's say, so this is 0, so this is -1, so this is 1, 2, 3, 4, 5, 6, on and on. Okay, now so let us see what is my domain. My domain is what? X cannot be equal to 3, so that means I'm going to put a hollow circle here, and x cannot be equal to 4, so I'm going to put a hollow circle here. So except these 2 points, I have domain for the whole other thing, for the whole other so let me choose another color. Yes, let me choose yellow. So for this number line, so what is this number line represent? Negative infinite until 3, and remember 3 is excluded, so that is the reason I am putting a parenthesis, not bracket. Now then also in between 3 and 4 also included in my solution, so it is what? 3 to 4 is also included. Now again remember 4 and 3 both are excluded, so that is the reason I am putting parenthesis. And then what is the last portion? Last portion is starting from 4 to infinite, so starting from 4 to infinite, and again 4 is excluded. So how I'm going to connect all this? I'm going to put a union sign. So this is the domain of my this particular problem 4. So this is the same domain. Okay, so that is how we should find out domain of any equation. So so in the next videos I'm going to try to explain how to solve a linear equation. So until then.